something a bit different for us today. This I want to make into a little test unit, and in the test unit I'm going to have my rolling rod situated at the front, and you'll see I've marked off a couple of areas, and in this one here I'm going to install an ammeter. This moving coil can go up to 500 mils, which hopefully should be enough for most locos that I'm working on. And on the opposite side we're going to have a voltmeter. The scales are 10 or 50, so I'll have to put it in 50 because I imagine I could be feeding up to 15 volts. On this side here I'm going to have my DC feed because this is where my power supply is, so I'll feed it through a 2.5 mil DC socket. And on this side, because my power supply for DCC will go over here, I'm going to fit a 6-pin DIN to match my Hornby select power feed, and I'll have a double pole, double throw switch somewhere, maybe here, maybe here, maybe here, I haven't decided yet, so I can switch between DC and DCC. And I think I'll probably include an on, off, on switch. So that's the idea. Okay, I'm hopefully going to be able to take these meters apart, provide a cutout which will let it sink down in there, and then I'll solder the wires onto here and here into the rest of the circuitry so it's not lying on top, and then a couple of feeds up into the rail, probably about the middle, to allow me to control the rail. So I'm going to make a start in trying to cut out the holes here and here, so I'm just going to finish off marking them. I'll get it cut and I'll come back when I've done that. Well, I've managed to cut out the recession hole for the left hand meter, and it's a very ungainly, it was horrible, it did a lot of hacking and cutting, even had the soldering iron to try and trim around the side, but eventually I got there, get it trimmed off, and the meter actually fits quite nicely into the recess like so, and that can be fixed underneath. So I now have to do the same for this side. But I'm going to try a different technique, and you can see I've made a cut here. This came from my mini cutter or mini drill, and so I'm going to try and use this to form a hole around the side. So let's see how that works. This will be noisy, folks. Well, it's certainly cutting through the upper surface of the ABS box, but when I turn it over you see it's making absolutely no impact through here. This is quite a thick box, probably about 5 mil, so I might have to do this quite a few times. I should point out that I'm wearing safety glasses in case of any cuts, so if you're doing this at home, make sure you're perfectly and adequately protected. So I'm going to finish off this, and when I've done that I'll come back on and let you see what's happening. and I've now made inroads into the plastic case by simply following the line and cutting deeper. So here goes for the other 3 sides. At this point you can see that I've got through most of the plastic on both sides. So if I push this, it should start to free, and the third side can be broken off. And there we have our second hole. Can I just point out that that noise you hear in the background is one of my neighbours power washing his lockbox driveway. So I'm afraid we may have to put up with that bit of noise in the background. But let's push on. So now I've got this here, what I'll do is get my meter, which is here, and make sure that it too is going to sit in the recess. My fear is always that I'll make the hole too big, and it just needs a little bit of trimming, but that's fitting in so neatly that you think it's professionally done, he says. So let me just go and get it trimmed up, get the meters fixed in, and then we'll take it to the next stage. There's my 2 meters embedded into the top of the ABS case. This one will be for current, and this one will be for voltage. So I'm just going to make sure that when I put the meter on, that these are set in the correct position. Maximum current for this is 500 milliamps, and the voltage I've set, I need to get more than 10, so I'm in a 50 volt range, so I should be reading round about here on the meter. That should be enough. It's only for testing, so it's not going to be accurate. So just to check and make sure that things are not untoward. Okay, let's leave that there. When it comes to wiring up my test board, I started off with a very crude wiring diagram. Here I've got DC input plus and minus, I've got DCC input with the AC, and what I tried to do is see where they met the 2 meters, and they both meet the meters here, voltage into track, and here voltage into track, and the ammeter on the negative return, so it's a case of fitting a switch in there. So then I wired up, thought of wiring up a double pole double throw switch, and you can see I've got my DC input, it's DC input, DCC, come through the switch, going to the voltmeter, the ammeter, and that's fine. And then I sort of put it together again. A couple of things came out of it, and I've kind of just thrown a couple of rough sketches as I went along, and that was that the DC can be either positive polarity or negative polarity. So I thought I'll fit in a point reversal switch in here. Ignore this, this is symbolic, nothing to do with the wiring, and what it means is that whatever polarity comes in here, I can get the same polarity out here to operate the voltmeter. Then I thought, well, what about an indicator? So as it happens, I bought one of these from Peter Spares. In fact, I think I bought 2, so there's another in the drawer somewhere, from the Glasgow fair earlier on in the year, and you think it's just a diode, but actually if I just plug it in, positive in there, negative in there, you can see that it's, I think you can see that it's in fact red. However, if I turn it round and plug it in the opposite polarity, it becomes a green LED. So this is a 2-color LED with 2 wires, which means if I put this across the input, it will tell me whether I'm in positive polarity or negative polarity. So on my control box, I'm going to put a switch in here on the DC side with the LED fitted, so that whatever colour this is, I can switch the switch so that it's always going to be polarity, the right polarity, going to the voltmeter and therefore through the current meter. If we can excuse that noise, it's been on all day. Don't buy lock block, folks, because you spend the whole day trying to clean it. Right, let's get back to this. I'm going to conduct a little experiment. In fact, to help you see what I'm doing, I'm going to bring in my power unit. So you can see here I've got an H&M control, forward, reverse, and obviously I can change polarity here. What I'm wanting is a bit of consistency. So if I put the control to forward, then I get a green light and the meter reads, at the moment it's about a 4 volts, 6 volts there. That's fine. But when I go on to reverse, then you can see the meter goes into reverse. And I don't want to damage the meter. You might also notice the red light came on. So instead of doing that, I'm going to try and not use the reverse control here. So if I want to, I'll have to use the reverse control. But in order to change the leads and so on, so I don't damage the meter, when that goes into reverse, the red light comes on, switch it to there, and the green light comes on, and I'm now reading a positive voltage in reverse. Does that make sense? Yes, I think it does. It means that I'm alternating the meter, and positive or negative depends on the control. And I don't have to keep switching the cables over, turning them round. I can keep it plugged in. I can turn this on and off the way I want. When it goes the wrong direction, I simply operate my polarity reversal switch. Good, that's working there. Well, I think it's time to put in my little machine to test, especially for DCC. And to help me test it, I'm going to use this little locomotive here. It's Graham Farish LMER 281, obviously. It's a tank engine. So I'm going to put it on, and I'm trying to work on the basis that as you look forward, the right hand side is the positive, and you can see I've got a red wire there. So I've got my power supply hooked in, and as I turn up the voltage, you can see it's positive, the green light is coming on, and the locomotive is moving forward. And I didn't actually notice it there, but it's taken about 200 milliamps, which I don't think is too bad. Right, if I then reverse the polarity of the controller, the meter's going the wrong way, so I switch this over, gone green, and oops, that's not what I expected. I'm having to revise my design because I've had a rethink about it, and what I need to do is put this switching after the track, because it's the monitoring I'm trying to reverse, not the track power. So I'm going to have a go at that, and I'll get back to you later on. Well, I've got another wiring diagram which I think might work. Got the DC coming in through the DC-DC switch, fade to the track. That's okay. The monitoring system will take a feed off from this side, which will go into the reverse polarity switch, and the whole voltage will be applied across the resistor and the diode. I'm not quite sure polarity of that yet, just going for symbolism. And the meter, the voltmeter, will be across the whole thing, and the ammeter is in series. The ammeter presents very little resistance to the voltmeter, so this should work. So if the polarity is reversed, then this is positive going there to the track, which will then be positive here, and this is negative, the negative there, which means that this will be positive here, which will be reversed to this one here, and therefore give the same polarity, and the negative will come in here and go across over to there, which will also give the same polarity. So the track is being controlled by the controller, and the monitoring is controlled by the switch. So I think that will work. Only one way to find out. Well, I've rewired my test unit according to my other diagram. So I've got the power coming in here, going to the DC-DC switch, and then to the track. And then I've taken a feed from here to the polarity reversal, which also feeds to the monitoring station. So now I'm going to test it and see what happens. Put the power up, I get a green light, I've got positive voltage. So that's good. I'm now going to reverse the polarity of the current, and there we go, negative voltage and a red light. This should give me a green light and a positive voltage, turning the control into the reverse, and that's what I've been looking for. I realized I had to change the monitoring system, not the supply system. There's that guy away again. 9:30 in the morning he's been doing that, and it's now gone supper time. Right, let's see if this thing works this time. This should be positive, so it should be going forward. And there we go. And negative in reverse. Pretty good. I'm a bit concerned because it didn't read any current. Forward, green light, negative, red light, negative, green light. I better check why there's no current reading. Here's my latest wiring diagram. DC in through the switch, DC position, one end goes to the positive end of the track, the other one comes through and is fed through a separate double pole double throw switch into the negative, out the positive, so it matches here, so the current will go through the motor, through there and back again. The voltage monitoring, as before, across the track, to show the voltage coming in. When the polarity of the input voltage is reversed, I switch the I switch this switch here, which is a 4-pole double throw, and that reverses all the connections to the voltmeter in parallel and the ammeter in series. So I went to Maplin's in nearest town, and this is my 4-pole double throw, which is basically 4 single pole double throw switches in the one casing. So I just split it into 2 halves, wire them up according to the diagram, fit it in, and that should be my problem solved. Well, I've wired in my 4-pole double throw switch. I'm not going to run through the wiring, but you can see it's coming in here, going to my power selector switch. There's 2 feeds of black and red coming to my 4-pole switch, and a red lead going to the track. Parallel to that is this black feed coming back to the switch. These red and green wires go to my voltmeter, and these 2 black and white wires to my current meter. Best thing to do, let's have a wee test. So, voltmeter, current meter, reverse a direction switch, and my locomotive. So this is set up so that if I wind this up correctly, this should be positive voltage, green light, current moving forward. Let's try it. Positive voltage, green light, moving forward, positive current. Change direction, negative voltage, red light, operate switch, positive voltage, green light, come on, and going in the opposite direction. Excellent. That's now working. Looking a bit shabby. I could probably do something with it later on, but that's it working. The only thing I have to do now is see what happens with DCC. And cut 3. Just a little final test to actually use it as a rolling road. I've got my DCC Concepts rollers on, so putting the power up and hope for good connections. Yes, it's starting to turn. I've noticed a kind of drop in the voltage. I've got it in a higher range right enough, and the current is holding very steady. That's about 16 milliamps at about 6 volts. And if I turn it up, and this is what I'm hoping I can do, is sort of set some sort of standard or benchmark so that I can compare, maybe record these numbers against individual locos. Put this down a little bit so you can see I'm almost over 9 volts here, holding steady at 20 milliamps. Just not a lot of current at all. Sorry, I'll make that 200 milliamps. That's a bit better, isn't it? 200 milliamps. So I could get 5 of these running off a 1 amp power supply. Right, I'm quite happy with that. Made a few elementary errors along the way, but from that I've learned a lot. I hope you enjoyed that. And maybe encourage some of you to make something a lot better, and you show us what you've got. I'm just going to change the voltage over into reverse. Yeah, there she goes. kicks in about 5 volts. Take it up as far as I can. There's 10. I would never have an 060 running at that speed anyway. But if I'm going to create a benchmark, I need to test it at certain conditions. I'm going to leave the DCC side just now because I haven't got a lot of DCC work doing. So thanks for watching, people. I hope you enjoyed that. Enjoy commenting. If you haven't already done so, subscribe to get more servicing videos from Sort6233, and hopefully you'll comment favourably. Looking forward to hearing from you. Meantime, keep watching YouTube, and bye for now.